Imagine this, a UFO is flying out in the sky. It spots a cow off into the distance. It flies over, hovers over the cow, and has its tractor beam straight down on the cow and levitates the cow slowly off the ground, up into the spaceship, and then flies off into the horizon to do whatever experiments it needs to do. Well, hi, my name's Pramil, and I'm here to talk about not about levitating cows, but about how to levitate smaller items such as water drops using the power of sound. I'm just going to show you a real quick clip of how that can be done. Just to point your attention, you'll notice that there's actually two speakers in the setup, one above and one below the polystyrene balls. And also you notice that they're actually levitating. There's no strings or anything attached to them. They're just free floating in space. And you'll see the same thing here now happening, but with little water droplets using a little syringe. You may have seen sound represented a bit like this, a little squiggly line that oscillates up and downwards. Now, to get an idea of what was happening in the clip I showed you earlier, we have to imagine that there are two waves, one coming from each speaker, in this case the blue and the red. And we have to say that they're both superimposing at different points and create what's called a standing wave. And this standing wave has some interesting properties. Here, where the standing wave is represented by the black line, and the red line is what represents the pressure at different points on the standing wave, we can say that there are points in the standing wave that have an incredibly high pressure and that keep on changing, and points in the standing wave which have no pressure changes at all. Now, in the same way that the table tennis bat is constantly pushing the ping pong ball up even though gravity is pulling it down, is the same way in which the areas of high pressure are constantly pushing the styrofoam balls up even though gravity is pulling it down. You may have noticed that all the styrofoam balls have a roughly equal distance between them. This is because the standing wave actually creates a regular pattern of where the high pressure and where the low pressure will end up being. Hence you can almost sort of guess where a ball is likely to float. So you may be asking yourself, what are the actual practical uses of acoustic levitation? And it's been found that certain cancerous cells have a different squeezability to their healthy counterparts. And using this, using acoustic levitation, we can test the physical properties of cells and determine whether they're cancerous or not. And acoustic levitation is an awesome way to do this because you're using the high pressure, which means you're not actually making any physical contact with the cell. Levitation using standing waves. I hope you enjoyed that, and thank you for listening.